Okay, I hope you guys have joined it. So let's officially begin. Right, so even though this is a 1.5 hour Head Start program, honestly, I think we'll be done within 1 hour. Then you guys are free to enjoy the rest of your Thursday night. Okay, so let's start with some introductions. Okay, so hello, I'm Hanjin. You guys may have seen me on some of the previous Overmark podcasts. Okay, so I'm actually the lower secondary science tutor with Overmark, and I'm actually a part-time tutor. So if you guys didn't know what exactly Overmark is, your friend just dragged you to join this Head Start program. Okay, so Overmark is not really a tuition center. It's more of a platform. So you can consider it like Shopee. Okay, it's a platform and we have a few tutors on board. So some of us are full-time tutors and some of us are part-time tutors. So personally for myself, I'm a part-time tutor. Okay, I started officially tutoring after my A-levels ended in 2018. So I have 3 years of tutoring experience. But I'm also a student, so I'm actually a full-time dental student now in NUS. And if you're curious about my educational journey, I was from Chongqing High School, Maine, and I took my O-levels and I went to Raffles Junior College. And then after that, I graduated and now I'm in NUS. Okay, so I know some of you may be slightly like curious about group tuition for secondary 2 students next year. So if you're interested in that, do stay tuned because I'll be talking more about it as well as having a Q&A session at the end of this Head Start program. Right, so what are we going to cover today? First of all, we're going to talk about what are the upcoming topics in secondary 2 science syllabus. And then I'll talk a bit about what are, I feel, the hardest upcoming topics that you should look out for or spend a bit more time, especially and pay attention in class. Okay, and then some revision strategy and tips. And lastly, I will be zooming in a little bit on the particulate nature of matter. Now, if you have already covered this topic in secondary 1 and you're not very interested in listening to it, that's perfectly fine. Okay, if you want to leave the call early, go ahead. But if you want to stay to the back to learn more about the group tuition, then just go and watch some TikTok or YouTube and then come back later. Okay? So, what exactly are we going to cover as secondary 2 students next year? So, generally speaking, right, when we look at our textbook, it is segmented into these themes, correct? So we have themes such as interactions and systems. Now, before I actually get into it, I would like to first say that for lower secondary science, right, the schools are super messy, which means that every single school will teach the topics in a different order. So unlike upper secondary, right, where let's say you have a textbook with chapters 1 to 20, most schools will go, oh, chapter 1, chapter 2, chapter 3. But for lower secondary, okay, different schools will really cover, like, for example, some schools will cover cells in secondary 1, but some schools will cover cells in secondary 2. Okay, so same. So some schools I know they cover like electrical systems in secondary 1, but some of them will cover in secondary 2. So in this list, okay, if you already have covered some of these topics, if your school has already tested them in your secondary 1 exams, don't panic. It doesn't mean that you'll be repeating these topics. Okay, it's just that for the textbook and for a lot of the schools, okay, they will be following these topics, which fall under interactions and systems theme. Now, you might think, the one you're going to cover today, particulate nature of matter, is literally not even here. Yeah, so precisely, because I know that a lot of schools will be covering the particulate nature of matter in secondary 2, even though it's technically a secondary 1 subject. Okay, so once again, don't be frightened or don't be alarmed that, oh, I've never seen these subjects before, or oh, I've already learned these topics. Okay, don't worry about it. This is just a general guideline. But within this particular list, okay, personally, the ones that I find to be much harder would be forces and transfer of energy, as well as electrical systems, especially electrical systems. Now, electrical systems is very, very tricky because you will be learning about different types of circuits. So you have the series, you have the parallel, and then in a lot of examinations, they will be combining both of them. Okay, but fret not, okay, if I ever get to cover such a topic again in another Head Start course, okay, we will run through it systematically in a way that helps you to understand. Okay, now for forces, some people find it quite easy. Personally, as a student, when I was learning it, I thought it was quite tricky because you have to think a lot about like how the energy is conserved, how is it transferred when, like, for example, a ball moves or a ball drops. Okay, but once again, don't worry about it. When this is not even the topic that we're going to be covering today. Right. So maybe let's move into some revision strategies. First of all, the first one, I do think that quizzing yourself is very important. Now, I'm not sure how many of you have heard of this revision strategy called like active recall. It's been very, very popular these few years, where essentially it basically centers around the idea of quizzing yourself. And this helps you to memorize and retain information. Now, the reason why this is important is because you're forcing your brain to recall the things that you've learned before. It's not very efficient if you just learn, then you don't revise your previous topics and stuff. If you think about it, right, the reason why we have multiple tests and multiple exams over the year, like along your school year, right, is because your school is actually forcing you to quiz yourself and practice a form of active recall. So even though they don't explicitly call it active recall, okay, the fact that you are taking multiple examinations is a form of quizzing yourself or active recall. Okay, so how do you actually implement this or try to use this in your revision strategy? You want to always quiz yourself and recap your information at the end of each topic. It's even better if you are able to do it like at multiple points within the topic itself. This makes sure that it helps you to make sure that your foundations are accurate and they're strong. Okay, how about the next revision strategy? It will actually be to do a lot of practice questions. I know a lot of people think, as long as I memorize the info, can already, don't need to practice, just need to mark, memorize the info. Yes, memorizing the info is an important part of your revision. But if you're not able to apply it in an exam setting, in an exam question, what's the point? Okay, so you will learn that whether or not your school exam or next time you take your O or N levels, right, a lot of the questions that come out in these exams are repetitive. They might have slightly different values. Maybe instead of 50 kg, the next one is 20 kg or 200 kg. But what they're trying to test you, the concepts they're trying to test you are always the same. And if you have practiced these questions before, it becomes really easy to you. When you see it, oh, I already know what this question wants. I already know how to answer it. I know what keywords to put in. Okay, this is why practicing is super, super important, and I'll prioritize it over anything else. All right. How about some other important tips? So first of all, right, you always want to get your foundational topics right before you can even think about scoring or acing. Okay, before you even think about, I want to get A1 for this subject. Okay, you must have your foundations there. For example, let's say the easiest topic, I'm sure most of you have done cells in secondary one, like biology cells, okay? Before you can even think about, how am I going to answer higher level questions like comparing plant and animal cells? Okay, first of all, you need to ask yourself, do you even know what a cell is? Do you know what the components of a cell is or are, and what are the functions of each component in a cell? Okay, so you get your fundamentals correct. Okay, then once you get that correct, you get your fundamental topic correct. Okay, because a lot of these subjects also build on each other, as you will see as you learn in next year's science topics. Okay, next, you want to clarify your doubts early. This means that if there's something that you're not sure about, you just think, I don't really understand this, concept that the teacher went through last week. Okay, don't wait until 1 week before your exams and you're like, oh my God, please, I need to consult you. Can you stay back after school? Okay, that'll be too late. As much as possible, you always want to clarify your doubts early, because that helps you set a foundation. So that sort of goes back to your first point of getting your foundations correct. Right? And lastly, you want to be consistent in your work. I'm not sure how many of you have watched or heard or listened to the podcast I did with Daryl like about a year back, where we talked about how I scored in O levels. But a point that I brought up back then was the fact that I was very, very consistent with my work. So even though I wasn't studying very hard like all the time, right, I was consistent. I made sure that, okay, I do my homework. I don't let myself like suddenly pile up like, one huge stack of stuff that I have to do. So being consistent, okay, also helps to allow you to build up good learning habits. Okay, and this will help you way down the road, even when you go to your JC, go to poly, go to university. Okay, it helps you to have this foundation and your good learning habits. Now, let's jump straight into the particulate nature of matter topic. Now, once again, if you've already done this topic in secondary one, okay, that's good. You can always just mute this call first and then go watch some YouTube videos. I'll be done in about 15 minutes, I think. Okay, and then come back after that. Right. And for those of you that are not sure whether or not this will be one of your earlier topics tested in secondary 2, or you're just curious about what exactly is this topic, I've never heard of it before, okay, I urge you to stay tuned to listen to me, also because this is a very, very important topic in your upper secondary chemistry. So if you're able to get a general sensing of what exactly it entails, what is required of you, okay, I think it will be beneficial to you. Right. So first of all, what is matter, right? Matter is anything that occupies space and has mass. Literally anything, okay? I'm made of matter, you are made of matter, okay? Your water bottle is matter, your phone is matter, your laptop is matter, okay? Anything in the world, oh goodness, wait Can you guys see the words on the slides? Can someone give me a thumbs up, thumbs down? Because I'm not seeing it. No? Okay. Give me a second. Can you see it now? Okay, great. So sorry, I think my iPad hanged a little bit. Okay, so matter is anything in this world that occupies space and has mass. Okay, so once again, I'm made of mass, you're made of mass. Okay, anything in your book, your textbook, all made of mass. Oh, sorry, made of matter. I'm so sorry, made of matter. Now, here's a quick question. Is air matter? Can someone type in the chat, do you think air is matter? Yes. How come? Can someone tell me why? It takes up space. Very good. Okay. Very good. Okay, so this is actually a misconception that a lot of students had, like when they first started learning this topic. They're like, oh, but I can't see air, like I'm moving through air, right? So how does it occupy space? Okay, now whenever you get confused about stuff like this, right, think about a simple experiment where you blow up a balloon. Okay, you have a small balloon. Okay, if I draw, this is the uninflated balloon, correct? Then you blow it up, oh, it becomes very fat. Okay, why? Because you've blown it up with air. Air is within this balloon. It takes up space that allows the balloon to expand in size. Okay, and if you really wanted to measure the mass, okay, between this and this, okay, there'll be a very, very slight difference. Maybe this is like 0.02 grams. This will be 0.05 grams. Okay, it does have mass. Therefore, we also say that air is a form of matter. Now, another question, is a shadow made out of matter? No. Okay, very good. Correct. Okay, the reason why, because shadows do not occupy space and they don't have mass. Okay, yeah, you can say, oh, I see the shadow on the wall, right? I mean, that looks like it occupies space, but no, it doesn't. Okay, so very good. You guys have a fundamental understanding of what matter is, which is anything that occupies space and has mass. In your exam, if they ask you to define matter, okay, this is your definition. And there are 3 physical states of matter. I'm sure you've learned this, generally speaking, in your primary school also. Right, so you have your solid, you have your liquid, and your gas. And what defines its physical state, right, is actually its boiling and melting point. So let's say we want to go from a solid to a liquid. What process will this be called? Okay, very good. Yes, this is a melting. Okay, how about liquid to gas? Very good, boiling. Okay, there's actually one more process, and that is evaporation. Now, I won't really talk too much about what the difference between boiling and evaporation is. Okay, if we have time, we can come back to it. All right, but both of these processes involve a change in the state of matter from liquid to gas. Now, how about, let's go backwards. What about gas to liquid? What would that be called? Okay, very good. Condensation. Right? Like when you take your can of Coke out from the fridge and then suddenly you see a lot of water droplets on the side of your Coke can. Okay, why? Because condensation has taken place. Now, how about liquid to solid? Last one. Okay, very good. Wow, very fast. Okay, freezing. Very good. Right. Okay. So the thing that determines the physical state of any matter is its melting or boiling point. This means, right, for example, if I'm talking about something at room temperature right now, okay? If its melting point is below room temperature, what state do you think it will be? Melting point below room temp. What state do you think it will be in? Okay, maybe you guys are getting a little confused now. Okay, this is where a lot of students get confused. And I'll teach you a hack method. Okay, once you have this method, right? Okay, you will never get this question wrong again. Okay, someone asked, what did I ask? Okay, I asked, if a substance, let's say substance X, okay, has a melting point that is below room temperature. At room temperature, what state is substance X? Is it a solid? Is it a liquid? Or is it a gas? Okay, so I see a little bit of confusion now. Don't worry about it. Okay, I'll teach you a hack method. All right, great. So, okay, I'm going to take this page from the low secondary science curated notes. Okay, so if you guys are considering buying this, you can also wait to the end. Okay, I'll send you the QR code and all the information that you need. Okay, but in this, okay, let's take a look at an example. I said the melting and boiling points of some substances A to D are given in this table below. Which of the following is a liquid at room temperature? So how do we solve a question like this? Okay, sounds very convoluted, very, I don't know what's going on. Okay, don't worry. There's an easy method to this. First of all, before we get into anything, we need to define what temperature is room temperature. Okay, room temperature, generally speaking, it will be 25 degrees Celsius. Okay, now they're asking us, which of these substances will be a liquid at 25 degrees Celsius? Right. Oh, okay. Don't say the answer yet. Wait, let me explain to those who may be a little bit more confused at this point. Okay. So, what I want you guys to do when you come across these kind of questions, they're asking for the physical state of matter at a certain temperature. Okay. Draw this line out. Okay. And I want you to have 2 points here. This is your melting point, and this is your boiling point. Now, anything on the left, okay, left here of your melting point, okay, so that means at a temperature below the melting point, okay, is going to be a solid. Okay, so for example, let's say my melting point is, my melting point is 25 degrees Celsius. Okay, at 24 degrees Celsius, 20 degrees Celsius, 10 degrees Celsius, okay, it's going to be a solid. And then at 30 degrees, at 50 degrees, okay, whatever, it's going to be a, okay, let me change color. This is going to be a liquid. Okay, and similarly, okay, this is the part that I demarcate, right? Okay, on the right of that is going to be a gas. So anything above the boiling point is going to be a gas. If I say my boiling point is 100 degrees Celsius, okay, if it's 120, if it's 1000 degrees Celsius, okay, it's going to be a gas. Does it make sense so far? Okay, let me erase it because it's a bit messy right now. Okay. So once again, all I need you guys to know at this point, right, okay, is to draw this line out. Okay, I have 2 points. Okay, one is your melting point, one is your boiling point, and everything below your melting point is a solid. And then this middle part is your liquid. And then on the right here, it'll be your gas. So what I want you guys to do, right, is to do step by step each option. So let's take a look at option A, right? The melting point here is 824 degrees Celsius. 824 degrees Celsius. Now, room temperature is 25 degrees Celsius. Is that to the left or right of this? Is it smaller or bigger? Think about this like as a number line. Would 25 degrees Celsius be on the left or the right of this? Left. Very good. Okay, 25 is obviously smaller than 824. Okay, so it means that A at room temperature of 25 degrees Celsius is going to be a solid. Okay, now let's take a look at the second one. Let's take a look at B. Okay, I'll erase this one. Now, B, okay, the melting point here is negative 189. Okay, negative 189. Think about this as a number line, okay? And the boiling point is negative 30. So it's getting hotter, but it's still a negative. Think about this, it's like a winter country. Now, 25 degrees Celsius is way hotter, right? It's a positive value already, which means that 25 degrees will all be somewhere here. Okay, so this means that B, okay, at 25 degrees Celsius will be a gas. Okay, so this will be solid. This will be a gas. Okay, now let's go to option C. Now we're going to change the values again because these values depend on the option that we are looking at. Okay, so I erase this one again, okay? Option C is negative 39 here and 357 here. Where do you think 25 lies on this number line? Middle, very good, okay? Very good. See, 25 will lie somewhere between negative 39 and 357. So therefore, you already know, okay, C has to be a liquid. My answer will be C. Okay, this method really applies to any question that's asking something similar. It doesn't matter whether they're asking about room temperature. They can say, oh, what is the physical state of a substance at 3000 degrees? And then they give you the melting point and the boiling point. Okay, once you draw out this number line, okay, you demarcate where, okay, my melting point is, where my boiling point is, and then you figure out at this particular temperature, is it on the left, is it on the middle, or is it on the right? Okay, you for sure will always get, okay, the state question correct. Make sense? Very good. Okay, now the next important subtopic of this topic, right, will be investigating the properties of matter. So there's 3 important properties that I want you guys to know. So the volume, the shape, and compressibility of each state of matter. Okay, so can someone tell me what is volume? Have you guys learned volume? How do we define volume? Okay, very good. Yes, volume is the amount of space that something occupies. So let's say, okay, I have my water bottle here, correct? Okay, the volume of this water bottle is going to be bigger than my phone because it occupies more space. Okay, very good. You must know the definition of volume. Then second of all, we have space. We have shape. Okay, I don't think we need to define what shape is, right? I mean, you have circle, you have square, you know what shapes are. And compressibility means I'll be able to compress it. Okay, now we need to know the properties of solids, liquids, and gases. So for solids, right, okay, we have a definite volume. We cannot change the amount of space that it occupies right now. For example, let's say I go back, okay, I have my phone here, correct? Okay, it's a fixed amount of space that it occupies. I can't do anything about this. It's like that, okay? Same, it also has a definite shape. It's a rectangle right now, but I cannot just suddenly make my phone into a triangle without changing anything, correct? Okay, so it's a definite shape and it cannot be compressed. No matter how much I try, okay, my phone is not going to get any smaller. So these are the properties of solids that we must remember. Okay, then how about liquids? We have a definite volume. Okay, the amount of space that a liquid has will always be the same. If I pour 50 ml of water into a jug, okay, I suddenly cannot just, 30 ml or 80 ml come out. Okay, it will always be 50 ml if I don't change anything else. How about the shape though? Okay, the shape is indefinite in a liquid. Okay, someone said slime is a liquid. Slime is kind of in between. It's not really a liquid, it's not really a solid. Okay, but obviously right now we won't be learning about slime now. Okay, when we're talking about these kind of topics, it's really just purely like solid, liquid, and gas. Okay, now it has an indefinite shape. Why does liquid have indefinite shape? Let's say I have 50 ml of water, correct, and I put it into my water bottle here. So it's occupying this shape. Okay, but let's say now I take a triangle cup and I pour my water into a triangle cup. Oh, the water became a triangle. Okay, so it means the shape of liquids can be changed. And then lastly, right, I put here difficult to be compressed. Okay, we won't write in our answers as impossible. because there will be very, very small spaces within your liquid that can be compressed. You cannot see with your naked eye, okay? Definitely, it won't be noticeable enough for you to say like, oh, how come I can squeeze water, okay? But if we're going all the way down to the atomic level, okay, it can be compressed. So in your answers in your exams, you want to say difficult to be compressed. Okay, and lastly, we have our gases. Okay, the amount of space that gas occupies, right, in the world around us, okay, is indefinite. It's not fixed. Okay, similarly for shape. Okay, makes sense, right? And lastly, you can compress gas. For example, let's say I have a syringe. Okay, I can't really draw a syringe. You know what a syringe is, right? Okay, syringe, whatever. Okay, and you have the plunger here. Okay, if I push the plunger, okay, I push it this way. Okay, you see, I'm compressing the amount of air. Okay, but you can't do this for solids and liquids. Now, we're gonna go into, oh dear, is it hanging again? Oh, it is. Sorry, yeah. Okay, we're gonna go into this thing called the particulate theory of matter. And it states three very important things that you must understand. First is that matter is made up of tiny, discrete particles. So remember I mentioned earlier that everything around us is practically made of matter. Like I'm made of matter, and you're made of matter, and my phone is made of matter. Okay, if we really zoom in, okay, like for example, if I use my phone, okay, it's my phone, my iPhone. Okay, and I zoom in all the way, okay, it's made up of tiny, tiny particles. That's what makes up matter. Okay, and the second fact, there are spaces between the particles. Okay, very small spaces, but as you can see here, there will be spaces between each individual particle. Okay, and lastly, these particles move in constant and random motion. You can't see it with your naked eye, obviously, okay, but these particles are always moving around. If there's space, it will move. Okay, now, you need to understand that the arrangement of particles in the different states of matter will differ. Okay, so for solids, generally speaking, it will look like this. That means the spaces between the particles are so small and it's so compact. Okay, and that's the reason why it cannot be compressed as well. Okay, for liquid, it's a little bit better. There's a bit more space. It's less crowded. Okay, you can think about solid as, wow, really peak our MRT train. Like, wow, you really like the person in front of you, the face is like right at your hair. Okay, I mean, your face is right at their hair. Okay, then liquid is like semi-peak hour. It's like, oh, after school, then you know the bus is very crowded. Okay, but there's still a bit of space for you to move around. If you want to sit down, you just push around. Okay, and gas is, wow, if you take a 6 a.m. train, like practically nobody. Okay, so that's how you want to think about things. Now, there are certain things that you need to memorize. Okay, of course, you want to understand it first, but you also have to memorize with regards to the particulate theory of matter. These four things: the distance, the arrangement, the motion, and the attractive forces of each state of matter. Okay, so we go one by one. We start with solids. Okay, first of all, remember, solids are always like this. Practically, okay, when you draw it, right, it will be super orderly and super packed. Okay, super peak hour MRT train. Okay, the particles are very close together and they are arranged in a fixed and regular pattern. Okay, see, 3 on top, 3 below. It will always be fixed and regular. Okay, and how do they move? Remember, when we go back to the key point of the particulate theory of matter, the particles are always moving in constant and random motion. Even though it looks like there's no more space, okay, it's still moving a little bit. It's vibrating in their fixed position. Okay, so think about like just shivering in the MRT train. Okay, a little bit. You can't really move, you can't walk around, okay, but you're still moving a little bit. And the attractive forces between the particles are extremely strong. Sorry, I think it's hanging again. Okay, attractive forces are very, very strong. Oh no. Now, for liquids, okay, the particles are close together, as you can see, but they are slightly further as compared to solids. See, there's a little bit more space. There's a bit more give. It's not just that you're shaking in your like standing position, okay? You can still move a little bit, stretch your arms a little bit, okay? And how are the particles arranged? in an irregular and a random arrangement. How do they move? They move over short distances and slide across each other. So these are your keywords that you want to remember. In your exams, right? When you're writing the arrangement of particles for liquids or gas or whatever, you have to use the correct keywords. Okay, that's how you score full marks. And we want to say that attractive forces between particles is strong. Okay, it's still strong, but it's less strong compared to solids. Lastly, for gases, the particles are far apart. Remember I said 6 a.m. MRT, really like nobody. The whole train seat is for you. The only other person you see is like three cabins down. Okay, there's an irregular and random arrangement of particles, and the particles move freely and randomly in all directions. They're bouncing all around. In the train, you can move. Every stop, you just change your seat. Doesn't matter. You're always moving around randomly. Okay, and the attractive forces are very weak in the gas. Okay, so this is a study tip, but personally for me, right, what helped me to remember things is to write things out in a table. Okay, I know a lot of people like to write linearly, like when they write notes, right, then like, okay, solids, then they say, oh, okay, this is point X, point Y, point Z, then, oh, liquids, then point X, point Y, point Z. You can do that, yes, but personally, I feel that it helps me to consolidate information when I write it out into a table like this. Why? It's also easier to compare information. For example, distance. Oh, then at one glance, I know, okay, this is solid distance, liquid distance, gas distance. But if I write it like this on a piece of foolscap paper, linearly down, okay, it's hard for me to write comparison answers in my exams. Make sense? Okay, but generally, right, everyone has a different learning style. You need to find out what works for you and what doesn't. Okay, so tables work for me. Do they work for you? You have time to figure out, you have time to experiment and try things out. Okay, so I recommend trying it out. Now, next. So right now, if I'm going to go through a word example, this is an exam question, by the way, okay? If the question asks, using a particulate theory of matter, explain why a gas at room temperature and pressure can be compressed but not a solid. Okay, very easy question. How do we answer this? We just want to go back to our table, literally, okay? Let me erase things first. Why can we compress a gas but we cannot compress a liquid? Okay, so out of these 4 key things that we are looking at, right, which one do you think will help us answer the question? Distance, arrangement, motion, or attractive force? Just guess. You can write your answers in the chat. Okay, I see distance. Anything else? Attractive force. Okay. Motion. Okay. I see distance. Okay. Very good. So actually it's a trick question. Why? Because it depends on how many marks this question is. But the one that you must have for sure, okay, is distance. Okay? So how should we tackle such a question? First of all, let's look at liquid and gas, because that's all the question was asking us. Why can we compress gases or we cannot compress liquids? Okay, so in our answer, first of all, right, okay, we want to address the distance. Gases have particle space far apart. Okay, and the spaces allow for compression. Okay, sorry, between gas and solid. Okay, but solids have particles packed closely together. Very, very close arrangement. Okay, that means that there's really not enough space for compression. Okay, does it make sense? So this is one of the very, very simple questions. Normally in exams, something like this will be like 2 marks. Okay, and if you write this answer, you get full 2 marks. Okay, a lot of these open-ended questions for this particular topic, okay, it can go all the way up to like 4 marks. Okay, they want to ask something so simple, but then as long as you're able to memorize this table, and you know at the first glance, oh, I know what they're asking for. I know I have to talk about motion. I have to talk about attractive force. Okay, these type of open-ended questions, you will get full marks. Okay, so this table has to be a holy grail, honestly. If you want a screenshot, you can, or you can just get the curated notes because this table is taken from the curated notes. Okay, and the very last thing for this topic that I'll be covering today is the idea of diffusion. So how many of you have actually learned a bit about diffusion in like bio topics in Sec 1? Raise your hand. Me. Ooh, okay. Very good. So can someone tell me the definition of diffusion? You can type in the chat. How come now everyone's silent? Forget the definition already. Okay. Okay, I see one answer. Okay. Okay, very good. So how do we define diffusion? By the way, this is quite important, especially if you all are considering taking pure biology in upper secondary. Okay, definitions are holy grail, must memorize. So diffusion is defined as the overall movement of particles from a region of higher concentration to a region of lower concentration. Okay, now this is the chemistry definition. And generally speaking, for chemistry, we don't really ask definition questions that much. So the biology definition is this, but a little bit different. So for bio, we will say net movement of particles. And then we will also say, okay, down a concentration gradient. Okay, but generally speaking, all I want you guys to understand is that diffusion involves the movement of particles, okay, from a region of higher concentration to a region of lower concentration. And I see that a lot of you have this idea, which is very good. Okay, so it means you've gotten your fundamentals down. Very good. Now, for this topic, particulate nature of matter, right? Okay, they tend to ask two types. Diffusion in liquids is your first type. So you can think about an example. Let's say I have a beaker of water, or okay, I have my water bottle again. Okay, and then I drop in a little bit of food coloring, red food coloring. Okay, I want this to look like blood. Now, at first it will be like, oh, there's a red splotch in my water, and then I don't do anything. I just leave it on my table for 20 minutes. Okay, I come back 20 minutes later, my whole water will become red. Why? Because of diffusion. Okay, so even though my example here is not related to the water bottle, let's take a look. So let's say here I have my dye crystals on the bottom. Okay, diffusion will cause it to move from area of high concentration, which is the bottom here. Okay, it will spread to an area of low concentration, which is the top. Why? The top has no dye crystals. Okay, so all these black little dye crystals are going to start spreading and moving inside this liquid, okay, until it's equal, until it's reached this thing called equilibrium, which means at the top, at the middle, or the bottom, okay, the concentration of dye crystals will be the same. Make sense? Following? Okay. So I just want you guys to know that diffusion can occur in liquids, okay? But the one that generally, I think they test a lot more, right? With diffusion in gas. Specifically, this one example, which is diffusion of bromine gas, okay? Which is here. How do they do it? Okay, they will have this container looking thing, okay, with a separator, like a glass plate. Okay, on one end, which is the bottom here, there'll be very, very concentrated bromine gas. And at the top here, it will just be normal air. Okay, and the glass plate separates it. Okay, and then what they will do is that they will take out the glass plate. Okay, and then eventually, if you leave it for 10 minutes, 15 minutes, okay, when you come back and see this container, you'll see, hey, it became a light brown color. Why? Because the bromine gas from here, okay, has diffused to here, an area of lower concentration, and then reached equilibrium. So after 10 minutes, after half an hour, after 1 hour, you come back, okay, you will just have this very nice light brown color. I don't know whether your schools will let you do it in like science, like chemistry lab, but for theory, right, really like almost all the schools that I know that test diffusion in gases will test bromine gas experiment. Okay, so for this, okay, diffusion is not a difficult concept to grasp. Okay, and whether or not you think about it, you probably experience diffusion a lot in your daily life as well. Like for example, if I spray perfume at one corner of the room, then at the other corner of your classroom, eventually your classroom will be like, hey, I can smell the perfume also. That's diffusion of your perfume particles, correct? Okay, in exams, how you score is you always want to have your correct keywords. So as you mentioned before, higher concentration, the region of lower concentration, movement of particles, stuff like this. Okay, and if you ever see the bromine gas experiment, okay, you already know it's a diffusion question. Okay, whether it's MCQ or open-ended. Okay, so that's sort of like a brief overview of this topic. If it's one of the first few topics that you're learning next year, then that's very good. You already know what your teacher's talking about, and you can focus on getting A for this topic. Okay, so I hope it has been good and that I have been clear. Okay, obviously there are certain things that I've not covered in this topic itself. It's not the whole topic. Okay, but I think I covered the main points and hopefully help you get a better understanding of what's to come in 2022. Now, let's talk about key milestones. 1 year to your EOY exams. Okay, in March, most of you will have your term 1 test. Okay, generally speaking, they will test about 2 to 3 science topics. Now, at this point, right, it's really okay not to score. Okay, if you got your term 1 test results, oh, I got a B4. Oh, I just passed. Okay, don't worry. Why? Because you're learning new content. Okay, don't be so hard on yourself and think, oh my gosh, I have to get A1 for every single subject, every single test, or I'm a failure. Don't think that way. Okay, think about yourself as climbing a flight of stairs. Okay, when you first start, okay, you start at the bottom. Okay, you may not know what's expected of you. You may not know what exactly the question is asking for, what type of keyword they want from you. Okay, and it's okay not to understand at this point. Okay, you're getting into the hang of things. Now, by May, end of May, you will have set for your mid-year exam. So this is one of the bigger exams. Okay, this is for you to get used to the exam format. Okay, term 1 test normally is a short test. Maybe it's a 45-minute test, 1 hour test. But for your mid-year exams, it'll be a full paper. So at this point, you must be able to really sit down and do your questions without getting bored, without losing your focus. Okay, so this is getting used to your exam format. Now, by term 3, end of term 3, okay, you have your September holidays, and right after that, or right before that, okay, you have your term 3 test. Now, this is time for you to master your previous topics that you learned in term 1, term 2. Okay? Once again, it's okay if you're not quite there, your goal yet. Okay, we're working towards it. And lastly, in end of October to November, you'll be sitting for your end of year exams. It will be an important exam because it will determine what subjects you can take in upper secondary. Okay, and at this point, go out. Really, everything you want to write, everything in your brain, just use it and score as the best as you can for your end of year exams. Okay, so these are your 4 key milestones. I mean, I'm sure you guys know already since you said secondary 1 already, right? So what I want you guys to think about is where do you see yourself in 1 year? Okay, and at your current pace, are you able to reach your goals? For example, if you're considering taking pure science, do you think that the foundation that you've built so far from your secondary 1 topics is sufficient? Okay, it doesn't have to be a really, really like exceptional goal. Okay, it doesn't have to be like, oh, I want to get straight A1s for everything. Okay, all you have to do is set a realistic goal for yourself. Okay, and then work towards it at a consistent pace. So once again, it's all about consistency. Okay, it's a marathon, not a sprint. I know you guys love to chiong all your stuff, right? Like 2 weeks before exams, but it's a good time to start now to start building good learning habits. Okay, so I wish everyone all the best for an exciting year ahead. There's about 2 weeks left before you start your Sec 2, so enjoy yourself. Go to Christmas Wonderland. If you can, I don't know, go shopping, buy Christmas gifts for yourself. Okay, and don't worry, it will be an exciting time next year. Okay, so I know some of you might have stayed to listen about group tuition if you're interested. So I will be opening group tuition next year, starting January, and it will be a small group. So it'll be about 5 to 8 pack size now. Okay, why? Personally for me, right, I feel that group tuitions are so much more effective than one-on-one tuition. I don't know, maybe it's because I'm a very peer pressure person. So when I see someone studying next to me, right, I'll study also. But if it's just me and a tutor, then I'll just end up talking crap with the person. So I do feel that having a small group actually helps a student learn now. Okay, it'll be 1.5 hours each week. Okay, and then similar to what I've been doing just now, I'll be running through topic by topic in detail, like much more detail, and I'll be going through like exam questions and how to answer them. Okay, and obviously there'll be worksheets and you will get a free copy of the curated notes. So if you're interested, okay, there will be a free trial lesson on the 29th of December, Wednesday, 7 to 8:30. So same time as now. Okay, you can scan the QR code to register first. Now, this isn't like any like login, so it's not like, oh, I want you to pay money to me or anything. Okay, it's really a free trial lesson. If you decide, I don't want tuition with you, or like, oh, my mom found me another tutor, or oh, actually, I don't really need tuition now. It's okay. Okay, you can always just come for the free trial lesson. It'll be fun. Okay? And of course, if you're considering like legit tuition with me, right? Okay, it will start 8 January next year. And it's either at Toa Payoh or online Zoom. The reason being is that I'm not sure where the people that are signing up are coming from. So for example, if a lot of students signing up are like, they're staying in Pasir Ris, then it doesn't make sense for me to host a class at Toa Payoh, correct? Okay, but if I had a choice, I would rather it be physical in Toa Payoh. Okay, but these are the things that I'll iron out with Daryl and the rest of the Overmark tutors over the next few weeks. Okay, it'll be 35 per hour. Of course, all the admin staff will be straight with like mommy, daddy lah. So don't worry about it. Okay. So I'll just give about 30 more seconds if you guys are interested in signing up for the trial lesson. Okay, you can scan the QR code here. Okay, I just realized the next slide also has the same QR code. Okay, so last slide. So once again, okay, 3 different QR codes I'll talk about separately. Okay, first of all, if you have not joined our Telegram group for lower secondary over here, okay, join it. Okay, you get a lot of resources. We'll talk about like when we release our podcast and stuff. There's also free notes. So basically, there's no downside of joining it. So just join it. Okay. So that's the first QR code. Now, second QR code. If you want to try the trial lesson for tuition, it will be up here. Okay. Once again, you're not committing to anything. Okay. If you decide, I really just want to come for fun. Okay, one lesson. Yeah, go ahead. Okay, don't worry about it and don't be stressed. Okay, and if you're deciding, oh, I'm not really looking for tuition now, but I'm interested in buying the curated notes. Okay, this is the third QR code that you can consider. Okay, so this is where you can order the curated notes. Okay, so I know someone asked me, will I be uploading my slides anywhere? This entire Zoom session, right, will be uploaded on our Overmark YouTube channel. So you just go to YouTube and you search Overmark. I think it'll be there. I will probably not be uploading the PDF version of what I just went through. Okay, reason being, right, because it's actually not the full topic. And I feel like if it's not the full topic and it's really just like an overview, it's not really useful for you also because your school notes will probably cover the same thing in time to come. Okay, but okay, if you really, really want the notes, right? Okay, message me on Telegram. I will send you, I'll put my Telegram handle in the chat. Okay? And I'll send it over to you. Yes, and this is also Q&A. So if anyone wants to ask any questions now, like about anything, about what I just went through, if it's not clear, or about the group tuition, about the notes, about the Telegram channel, about Overmark, about myself, about dentistry, yeah, feel free to ask. How much is the curated notes? It's $30 per set. Okay, we will have lower sec math, lower sec science. If you have any older siblings who are in upper sec, there's also upper sec curated notes and JC notes also. Okay, everything will be in the Google form in the QR code. And yeah, someone asked, am I from Chongqing, Maine? Yeah, I was from Chongqing, Maine. I miss it a lot. Yeah, I miss my temple school. Anyone else from Chongqing here? The rest of y'all can leave already, okay? Don't paise, legit. I'll just leave the slide here a while more in case anyone still wants to scan the QR codes. Okay, but for the rest, yeah, feel free to leave. I hope it has been a productive session. Bye bye, guys. Thanks for joining me on a Thursday night. Okay, I'll leave this up for another 10 seconds. Then I'll end the meeting. Okay, bye, guys. Have a good weekend ahead.